Hello, my name is Kimmo and I work as an area manager at K-Patents. Did you know that the global paper and board production exceeded 400 million tons in 2014 and has grown ever since? This video focuses on an important step in the paper making process, the brown stock washing. To obtain the main component of paper, the wood pulp, wood chips are cooked with a strongly alkaline solution. The product from this cooking process is known as brown stock because of its deep brown color. Before these fibers can be used for paper making, they need to be washed to remove as much dissolved material as possible and obtain a soft and fibrous pulp which is lighter in color. This process starts in the digester, where pulping takes place and the brown stock is produced. Following the cooking, the brown stock moves on to the fiber line, where it passes through a series of washers to remove as much dissolved solids from the pulp as possible before it goes to the bleaching plant. The cleaner the pulp, the less chemicals are needed in the following bleaching and chemical recovery processes. In theory, if we apply an excess amount of water for washing, we get extremely clean pulp. In practice, however, we should use as little water as possible because the water used for washing needs to be evaporated later, and this increases the energy costs. Contradictory? Yes, it is. The washing operation is a compromise. It is a trade-off between the evaporation costs and the chemical costs, and the aim of the operation is to find the right balance between these two factors. By optimizing the line operation, the mill guarantees the best economic and environmental performance. So how is brown stock washing optimized? Well, first we need to measure and evaluate the washing performance. This is done by using multivariable parameters. The two principal parameters to measure are called dilution factor and wash loss. The dilution factor indicates the used water amount per ton of pulp. Wash loss is the dissolved material or dissolved solids which were not removed in the washing, but instead continue to the bleaching stage. Other important parameters include mass balances, displacement ratio, and the Northern efficiency factor. These indicate the true washing efficiency and even help to further enhance it. The wash loss as well as these important parameters can be obtained real-time by using K-Patents inline solids measurements. Dissolved solids have always been used to measure wash loss and washing efficiency. However, it has not been possible to measure dissolved solids in line, and therefore the inorganic changes by conductivity have been used as a real-time wash loss indication. Another common method to indicate wash loss has been chemical oxygen demand, COD, as it correlates with bleaching chemical consumption. While as conductivity measures the inorganic changes, this laboratory test gives indication on the organic fraction of the total solids. COD has its place in laboratory, but it cannot be used for process control due to the considerable delay and labor involved. Total dissolved solids has proven to be the most suitable and most reliable parameter for measuring wash loss and washing efficiency, because it considers all washable solids, the organics and the inorganics. This is the only true measurement of wash loss. The K-Patent Safe Drive Process Refractometer measures total dissolved solids in line and in real time. The refractometer measures dissolved solids selectively without influences from fibers or bubbles. K-Patent's refractometers are delivered pre-calibrated and have no calibration drift, making them the optimal measurement solution for process control. With K-Patent's accurate and reliable total dissolved solids measurements, mills can monitor and optimize the whole fiber line as well as the individual brown stock washing steps. They can avoid process disturbances, improve washing efficiency and stability, increase production rates, decrease the environmental load, and substantially reduce operating costs. Brown stock washing optimization with K-Patents offers improved economics of the whole mill, resulting from the great energy and chemical savings and from a surplus of vapor which ensures self-sufficiency of the mill and which can be used to generate electricity to sell to the local grid.
Let's take a look at an example on how mill's economy can be enhanced through brown stock washing. If a standard size mill decreases the washing liquid by 1 cubic meter per ton of pulp, the black liquor dry solids increase 1.4%. The saved water and reduction in steam consumption bring yearly savings worth 1.2 million euros. If the mill sells the energy back to the grid, the yearly savings can rise as high as up to 3 million euros. Then, if this 1.4% solids increase is taken to recovery boiler, it will bring an additional 1.5 million savings in higher black liquor heat value. Now what about the savings in chemicals? In the same standard size pulp mill, cleaner pulp means less chemicals in bleaching. By decreasing the bleach load by 10%, the mill gets direct savings resulting from the bleaching chemical costs. In addition, the decreased bleach load improves environmental performance and enhances the pulp quality.
The investment might seem significant, however, the benefits obtained greatly enhance the productivity of the mill in such a way that allow a rapid return on investment, as soon as in 3 months. For more information, visit kpatents.com.